What's up everybody and welcome to a new video. And in this video we're going to go over my notes for the PEP8 style guide. So here the first note states that PEP8 contains guidelines on how to style your code, and the goal is to improve readability. Namely, if everybody uses at least a similar style, then it is easier for you to read the code from others and also vice versa. And it's also easier to read your own code that you've written some time ago. And the actual guidelines themselves are also designed with readability in mind and not, for example, ease of writing code. And that's because in general, more time is spent on reading code compared to actually writing code. So that is the goal of this PEP8 style guide. However, these are just guidelines and not hard rules. So for the most part, you should probably follow them, but you can also use your own judgment to ensure that your code is easy to read. And then here I also have a side note, namely this states that there are also other style guides. For example, the Google Python style guide. Okay, so that is what PEP8 is and why it was created. So now let's get to the actual content of the style guide, and we're going to start with naming conventions. And here we're going to start with the naming conventions for variables, which also, by the way, apply to parameters or arguments. And here the conventions are to use lowercase, and they can only consist of letters, numbers, and or underscores. So for example, what you can say is, for instance, to say here variable underscore 1. And if I set that equal to 1, then we don't get an error. However, you can start with a number. So if I say here 1 underscore variable and set that equal to 1, then we get here a syntax error. So this is something that you can do. And what you also can do is to use any special characters. So for example, if I say here variable underscore and then for example the $sign and set that equal to 1, then we also get here a syntax error. Okay, so those are the naming conventions for variables. Then next are constants, and here the conventions are to use uppercase, and they also can only consist of letters, numbers, and or underscores. So for example, what you can say is constant and then underscore 1, and if you set that equal to 1, then this doesn't throw an error. However, again, you can start here with a number. So if I say here 1 underscore and then constant and set that equal to 1, then we get here again a syntax error. And here also you can't use any special characters. So for example, if I say then here constant and then underscore and then again here the $sign and set that equal to 1, then we also get here a syntax error. So those are the naming conventions for constants. Then next we have the conventions for functions, which by the way also apply to methods. And here the convention is to use lowercase with underscores. So to show that, let's create here a function. And here what we can call it, for example, is to say here my underscore function. And then if I just put in your pass, then you can see that we don't get an error. So this is a valid function name. So those are the conventions for functions. Then next we have classes, and here the convention is to use capitalized words, i.e. camel case. So to show that, let's create here a class, and let's simply call this here my class. And then again, let's put in your pass. So if I run this, then we don't get an error. So this is here a valid class name. So those are the conventions for classes. Then next we have modules and packages. And here the naming conventions for modules is to use lowercase with underscores. And some example modules would be here the sys module or the spy underscore compile module. And then the conventions for packages is to only use lowercase, and using underscores is discouraged. So example, an example package would be here this URL lib package. And as you can see, this wasn't named, for example, URL underscore lib, because those underscores here are discouraged for packages. And then here I also have a side note, and this states that you should avoid giving your own modules and packages the same name as modules and packages from the standard library or from third-party packages. Okay, so those are the naming conventions here for modules and packages. And then lastly, we have here these special forms with leading and or trailing underscores. And the first special form that I want to cover is a single leading underscore. Namely, what that does is it indicates non-public variables, functions, or classes, or non-public attributes or methods. So to demonstrate that, I've prepared here this module. So this is called my module. And then here we have a public and non-public variable, a public and non-public function, and then here a public and non-public class. So now let's import this module into this notebook here. And we can do that because this notebook is in the same directory as this file. So then here, let's simply say import my module. And then here I'm going to say my module and then dot. And now if I invoke here IntelliSense to see what's available, then you can see that we only have here the public versions of this module and not the non-public versions. So that's the first example that I want to show. And now let's also here create public and non-public attributes and methods. So now let's create an instance here of this class. So therefore then here we're going to say instance equals my module dot public class. And then here, if I say instance dot, and then again, see what's available, then again, you can see that we only have access to the public attribute and public method and not to the non-public versions. Okay, so this is this first special form here that I wanted to cover. Then next we have a single trailing underscore. And the purpose of that is to avoid conflicts with Python keywords or built-in functions, i.e. to avoid overriding them. And to show what I mean by that, I've prepared here this code snippet. So here we have a function called greetCustomer, which takes in the parameters name and type. And then here we check if the type is equal to registered. Then we're going to print hello name, welcome back. Otherwise, we're only going to print hello name. And then here at the end, we are calling here this built-in function type because we want to know then the type of this name parameter. And then here I'm simply calling this function with the arguments John and registered. And now if I run this, then you can see it prints out hello John, welcome back. However, then we get here a type error for this line here where we call this, or where we want to call here this built-in function type. And it says then that the string object is not callable. So what's happening here is that this type here is not the built-in function type, but again, but it is instead referring here to this parameter, which is here a string, and therefore it's not callable. So now to get around this problem, we can use here a single trailing underscore for this parameter here. So therefore then we say here type underscore, and then here as well. So now if I run it like this, then you can see that we don't get an error. And again, it prints then out here, hello John, welcome back. And then here class string. So this name parameter is of the class string. So this is how we can use here a single underscore. However, here I also have a side note. Namely, this states that it is probably better to simply use a different name in the first place. So for example, instead of calling this parameter type, we could also call it simply here customer type. And then if I run it like this, then we also get here the same result and then avoid overriding here this type built-in function type. Okay, so those are my notes for this single trailing underscore. Then next we have double leading underscores. And what that does is it invokes something called name mangling. And this is a more advanced topic, which I'm not going to cover in more detail. However, this is helpful when you use inheritance. So those are my notes for the double leading underscores. And then lastly, we have double leading and trailing underscores. Namely, they are called magic or dunder functions, magic or dunder methods, or magic or dunder attributes. And an example of that would be the init method. So if you don't know what it is, then I will put a link to a respective video into the video description. And here a guideline is to never invent such names, only use them as documented. Okay, so with that now we've covered here all these special forms. And with that then we've covered here all the naming conventions that I wanted to cover. Then the next section contains guidelines with respect to the code layout. And here the first guideline is about the maximum line length. Namely, this is set to 79 characters for code or 72 characters for comments. And the purpose of that is to be able to have multiple files next to each other on the screen without invoking a horizontal scroll bar or without messing up the layout of the code due to a default wrapping behavior of the specific tool that someone is using. And then here I also have a side note. Namely, this states that the maximum line length of 79 characters is somewhat controversial. Okay, so those are my notes for the maximum line length. Then next we have indentation. And here the general guideline is to use 4 spaces per indentation level. And then here the next note is about continuation lines. And here you can take advantage of the implicit continuation behavior within parentheses, brackets, or braces. And the first example that I want to show here is with a nested data structure. So to show that, I've prepared here this nested list. And then here, let's see what the indentation with such a nested list should look like. So therefore, I'm simply putting here this first inner list on the next line. And then here it's automatically indented with 4 spaces. Then I'm also doing this with this second inner list and then also with this third. And then here for those closing brackets, you can either put them or align them vertically here with those opening brackets of those inner lists, or you can also put them at the beginning of the line. So this is what the indentation for a nested data structure should look like. Then next we have functions, and to show that I've prepared here this function. So here we have a function with a very long function name and then also a lot of parameters. So now let's see how we can use indentation in this case. So one approach would be to simply align those parameters here vertically, and you can also do that here in the function call. So that's the first option. And another option would be to create a hanging indent. So therefore, then we indent here this first parameter. And then after that, we can then align those parameters here vertically. And again, we can also do that here for the function call. So in that case, it then would look like this. And then here, those closing parentheses, we can then also put here at the beginning of the line. So this is what an indentation should look like with respect to functions. Next, we have arithmetic operators. So to demonstrate that, I've prepared here this example calculation. So now let's see how we can use indentation in this case. So therefore, let's copy here this line. And then here, to take advantage of this implicit continuation behavior, we're going to put those variables into parentheses. So now to use indentation, what we can do, the first approach that we can use is to simply align those variables here vertically. So therefore, we're going to put those simply on a respective line. And then let's also here indent the weight a little bit. So this is the first approach that you can take. And the second approach would be to again use a hanging indent. So therefore, we're going to put those here into parentheses. And then here put also the wage on a new line. And then again, let's put all of these variables on a respective line. So then it looks like this. And then let's also again indent this wage a little bit. And then here this closing parentheses, you can then also put on a new line. And then here at the beginning of this new line. So this is what the indentation could or should look like with arithmetic operators. And then lastly, we have if statements. So to demonstrate that, I've prepared here this if statement where we have a lot of conditions. So let's see now how we can use indentation in this case. So therefore, let's first put all of these conditions here into parentheses. So this way then we can again take advantage of this implicit continuation behavior. And now we can simply put each condition here on a new line. So let's also here put this third condition on a new line. And then here for this third condition, we can also then align that with those other conditions. So this is how you could use indentation with if statements. However, now here we have a problem. Namely, since we're using here this if statement and then a space and then those opening parentheses, this equals 4 spaces. And this equals the natural indentation that we should use. So therefore then there's not really a clear distinction between this if statement and then the code within that if statement. So for example, if we just have one condition, then here this condition and then the code within the if statement, they are not vertically aligned, so they are visually distinguished from each other. However, here they are vertically aligned, and it's not really clear or not really that easy to distinguish what is the if statement and what is the code within the if statement. And PEP8 doesn't really take a position if you should actually further distinguish it or not. So therefore, my suggestion would simply be to put in here a blank line. So this way then, you have a clear distinction between the if statement and then also the code within the if statement. Okay, so those are then the examples that I want to cover with respect to the implicit continuation behavior within parentheses, brackets, and braces. Then the next note states that you can also use the backslash as a line continuation character. So to demonstrate that, let's again use here this calculation that we had before. And now if I run it like this, then we get here an indentation error. However, if I put in here a backslash at the end of these lines, then we don't get here an error. So this is how I can use the backslash as a line continuation character. However, this is generally not suggested to do. However, there are also some exceptions. For example, long multiple if statements cannot use this implicit continuation behavior. So in that case, then you would need to write the code like this, where you then use here this backslash as a line continuation character. Okay, so those are my notes for continuation lines. And with that now, then we've covered all my notes with respect to indentation. Then the next note is about whitespace. And here the general rule is to avoid extraneous whitespace, especially trailing whitespace. And then here the second note is about where to use whitespace. Namely, all operators should be surrounded with a single space. So to demonstrate that, I've prepared here this code snippet. So here you can see all operators are surrounded with a single space. So arithmetic operators, comparison operators, membership operators, identity operators, and these Boolean operators. And here, however, there are also some exceptions. The first one is that there are no spaces around the equal sign when used with parameters or arguments. So to show that, I've prepared here this function. So here you can see we are not using a single space around this equal sign here for these parameters, and also not here for the arguments. So that's the first exception. The second one is when you want to highlight the precedence when using different operators. And this here is optional. So for example, let's say we would have here such a calculation where we calculate 5 times 2 plus 3 times 4. Now to make or to highlight the precedence of this calculation, what you can do is here remove those spaces around the multiplication. So this way then it's easier to see what numbers are here calculated together. Okay, so those are those exceptions. Then here the next note is about a single space after a comma. So that's also where I use white space. So for example, if you have here a data structure, then here we have a single space after the comma. And then here there's also an exception. And that exception is when you have a trailing comma. So for example, if we have here a set with just one element, then you don't put a white space, after this trailing comma. Okay, so that's that. And then the next place where you use white space is with dictionaries. Namely, there's a single space after the colon. So therefore I prepared this dictionary. So here you can see there is a single space after the colon. And then lastly, the last place where I use white space is with slicing, namely when using more complex expressions for the start, stop, and step. And to show that, I've prepared here this code example. So here, let's say that for the start, we specify here a lower plus some offset, and for the end, we specify an upper plus some offset. So to make this more easily readable, you can put your spaces around the colon. So those are all the spaces where to use white space, and with that down, then we've covered here all my notes with respect to white space. Then the next guidelines are about blank lines. And here the first note states that functions or classes are surrounded by 2 blank lines. And additional blank lines may be used sparingly to separate out groups of functions or classes. So to show that, I've prepared here this code snippet. So here we have function 1 and 2, and they are separated by 2 blank lines. And here we have helper function 1 and 2, and they are also separated by 2 blank lines. However, then those 2 groups of functions here are then separated here by some additional blank lines. So that's the first note. Then the second note states that methods are surrounded by a single blank line. So to show that, I've prepared here this class. So let me copy and paste that. So here we have method 1 and 2, and they are separated here by 1 blank line. And then here, the last note states that within functions, blank lines can be used sparingly to separate out logical sections. So to demonstrate that, I've prepared here this function. And here you can see that I've put in here a blank line between this for loop and this if-else statement. Okay, so this is then how blank lines should be used. Then the next guidelines are about import statements. And here the first note states that import statements are put at the top of the file, and they are put after the docstring and before any global variables and or constants. And then the next note states that multiple modules or packages are imported individually on separate lines. So example, what you don't do is to say something like this here, where you import OS and then comma sys. And even though this works, you shouldn't be doing that. Instead, you should simply say import OS and then on a new line import sys. However, importing multiple things from the same module or packages can be done on one line. So for example, here I have this import statement where we then from URL lib we import request and pass. So this is allowed to do here to import multiple things from just one module or package. And then the last note states that those import statements should be grouped in the following order. So first you import modules or packages from the standard library, then third-party packages or modules or packages, and then your own files. So for example, here I've prepared such import statements. So here first I import modules or packages from the standard library, then here some modules or packages from third-party providers, and then here my own module or package. And as you can see, you always then put here a blank line between these groups of import statements. Okay, so with that now we've covered here all my notes with respect to import statements. Then the next guidelines are about return statements. And here the first note states that an explicit return statement should be present. So for example, what you shouldn't be doing is to create a function like this, where there is no return statement, even though this works, but instead you should then simply put in this return statement. So that's the first note. And then the second note states that either all return statements in a function should return an expression or none of them should. So for example, what you shouldn't be doing is to have a function like this, where you have these two return statements, where the first one here returns an X and the second one returns here nothing. So in this case, what you should do is, for example, that the second return statement here simply then returns a none. Or what you also could do, which doesn't really make sense for this function here, is that none of these return statements return anything. Okay, so those are my notes for the return statements. And then the last guidelines are about compound statements. So what is a compound statement? It's simply when there are multiple statements on the same line, and they are generally discouraged. However, sometimes it is okay to use them with an if statement, a for loop, or a while loop with a small body. So for example, to show that, I've prepared here this variable. So this is called number and set equal to -5. And now let's say, for example, here if number is smaller than 0, and then here, instead of going to the next line, what you can do is simply stay on this line and then say print, for example, negative number. So now if I run this, then you can see that it works and it prints here negative number. So these are my notes for the compound statements. And with that, now we've covered all my notes with respect to the code layout. And then this last section here is about comments. And here I first want to cover some general guidelines. And the first one is that code should primarily speak for itself. However, if additional information is necessary to make it more clear what is going on, then use a comment. So it's the first guideline. Second guideline is that comments should be kept up to date. And that's because comments that contradict the code are worse than no comments. And then the last guideline is that comments should be full sentences with 2 spaces after the period. And if the comment is short, then no period is needed. So those are the general guidelines. Then the next note is about the different types of comments that are available. And here we have block comments, inline comments, and the docstring. So let's start here with the block comments. So here the first note states that each line starts with a pound symbol and a space, and everything that comes after that doesn't get executed as normal code. So to demonstrate that, let me put in here 2 print statements. So we're going to say print 1 and then print 2. And now if I run it like this, then it prints out here the 1 and the 2. And now, however, if I put here a pound symbol in front of this second print statement, then this now is here a comment. And then if I run it, then you can see that it now only prints here this first print statement. So that's first note. The second note states that block comments apply to some or all of the code that follows them, i.e. they can be used like headings. And to demonstrate that, I've prepared here this large decision tree algorithm function. So here you can see that this block of code does something with data preparations. Then this block of code here are the base cases. And then here we're going to enter the recursive part of this function. And then here, for example, we're going to use some helper functions and so on. So as you can see, you can use block comments like headings. Then the next note states that block comments have the same indentation level as the code. So to show that, I've prepared here this code snippet. So let me copy and paste that. So here you can see we have another comment, and this is for this block of code here. And as you can see, this comment here has the same indentation level then here as this block of code. So that's the first note, a third note. And then lastly, the last note states here that paragraphs are separated by a line with a single pound symbol. So to demonstrate that, I've prepared here this comment. So here you can see that we have different paragraphs, and those are separated here by those pound symbols where there's no space after the pound. Okay, so those are my notes for block comments. Then next we have inline comments, and they are on the same line as the code, and they are separated by at least 2 spaces. And you create them by starting with a pound symbol and then a single space. And they should be used sparingly, only when something really needs to be clarified. So for example, to show that, I've prepared this little code snippet here. So here we have x equals x plus 1, and here it might not be clear where this 1 is coming from or what it should be for. So therefore then here you can create an inline comment that then says compensate for border. Okay, so those are my notes for inline comments. And then lastly we have the docstring. And here I first want to cover a definition. Namely, docstring means documentation string, and it's a string that occurs as the first statement in functions, methods, classes, or modules and packages, and it simply describes their behavior. And then here I also have a side note. Namely, it says that the docstring gets depicted in parameter hints. So for example, if I say here print and then invoke here the parameter hints, then we can see here the docstring of this print function. Okay, so that is the side note. And with that, then we've covered how the docstring is defined. So then the next note is about some rules. And the first rule is that docstrings are specified with triple double quotes. The second rule is that they are written as a command. So for example, you would say return list instead of returns list. And then here the last rule is that there are no blank lines before or after the docstring. There is, however, one exception. Namely, there's a blank line after the docstring in classes. So those are the rules. And then the last note is about the different types of docstrings that are available. Namely, there's a one-line docstring and there's also a multi-line docstring. So let's start here with the one-line docstring. Namely, every public function, method, class, or module or package should contain at least a one-line docstring. So to demonstrate that, I've prepared here this example function. So here I've created this docstring that says calculate the sum of the list and return the result. So this is what a one-line docstring for a function could look like. And then let's get here to this multi-line docstring. Namely, this can provide more details. So for example, for a function, this multi-line docstring could look like this, where we first have a summary sentence of what the function does, then a blank line, then a more detailed description if that is necessary, then describing what the parameters or arguments look like, and then lastly describing what the return values look like. So for example, to show that, I've prepared this example function here. So let's copy and paste that. So here we have a multi-line docstring. So first here a summary sentence, then here some more detailed description. Then here we describe what the parameters look like, and then lastly here we describe what the return value looks like. So this is what a multi-line docstring for a function could look like. And then for classes, the multi-line docstring should summarize the behavior and then list all available methods and attributes. And then here for those methods in turn, you would also then have each then a docstring. Then next we have modules. Here the docstring should list classes, functions, and any other objects that are exported by the module. And then there should be a one-line summary for each object. And this summary is then less detailed than the summary line in the object's docstring. So those are modules. And then lastly, we have here packages. So here the multi-line docstring should list the modules and sub-packages exported by the package. Okay, so with that now, we've covered here all my notes with respect to the docstrings. And with that, then we've covered all my notes with respect to comments. So therefore then we've covered here all my notes for the PEP8 style guide. And lastly, with that in turn, we've covered then all my notes with respect to Python. So therefore then we've reached the end of this series. So thanks for watching, and hopefully I see you again in another series.